Hello students, we continue with Newton-Raphson's method problems. So fifth problem, using Newton-Raphson method, find the root of the equation tan x equal to x near to x equal to 4.5, correct to 4 decimal places. First, write the given data. F of x is tan x minus x. X naught is given as 4.5. So f dash of x, derivative of tan x is secant square x. Derivative of x is 1, secant square x minus 1, which is tan square x. Now the Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn whole divided by, xn plus 1 equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, etc. First iteration, for n equal to 0, the formula becomes x1 equal to x naught minus f of x naught divided by f dash of x naught, that is x naught minus tan x naught minus x naught divided by tan square x naught. Here x naught is given as 4.5. One thing you have to remember, students, here is trigonometric function f of x and f dash of x. So we have to use calculator in radian mode. So when you substitute x naught as 4.5, we get x1 value as 4.49361. Now the second iteration, for n equal to 1, the formula is x2 equal to x1 minus f of x1 whole x1 f of x1 divided by f dash of x1. It is x1 minus tan x1 minus x1 divided by tan square x1. So x1 is 4.49361. When you substitute these values here, we get x2 as 4.49341. The third approximation or the iteration, which is obtained by substituting n as equal to 2. So x3 equal to x2 minus f of x2 divided by f dash of x2, which is equal to x2 minus tan of x2 minus x2 divided by tan square x2. Here x2 is 4.49341. When you substitute these values in this equation, we get x3 as 4.49341. Therefore, required root is x equal to 4.4934, correct to 4 decimal places. Now, the next problem, sixth one, using Newton-Raphson method, find the real root of x log x to the base 10 is equal to 1.2, which lies near to x equal to 2. So x naught is given as 2. We have to find the answer for 4 decimal places. Solution, f of x is given as x log x to the base 10 minus 1.2, x naught is 2, and we know that derivative of log x to the base 10 is 1 by x into log e to the base 10, but the value of so f dash of x becomes, apply product formula, first function is x, derivative of log x to the base 10 is here 1 by x into log e to the base 10 plus second function is log x to the base 10, derivative of x is 1. So when you use calculator, here x and x cancels. When you use calculator, log e to the base 10 value is 0.43429 plus log x to the base 10. Now the Newton-Raphson method is given by xn plus 1 equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, etc. The first iteration is obtained by substituting n as 0. So the formula is x1 equal to x naught minus f of x naught divided by f dash of x naught. So it will be x naught minus x naught log x naught to the base 10 minus 1.2 divided by f dash of x naught will be 0.43429 plus log x naught to the base 10. We know that x naught is 2. When you substitute x naught here, we get x1 as equal to 2.81317. Now the second iteration, for n equal to 1, the formula will be x2 equal to x1 minus f of x1 divided by f dash of x1, which is equal to x1 minus x1 log x1 to the base 10 minus 1.2 divided by 0.43429 plus log x1 to the base 10. We know that x1 value is 2.81317. So when you substitute this x1 here in this equation, we get x2 as 2.74111. Now the third iteration, for n equal to 2, x3 equal to x2 minus f of x2 divided by f dash of x2. It will be equal to x2 minus f of x2 is x2 log x2 to the base 10 minus 1.2 point divided by 0.43429 plus log x2 to the base 10. We know that x2 is 2.74111. So we get x3. If you substitute here x3 value as 2.74065, we have to get the answer correct to 4 decimal places. So the next approximation, for n equal to 3, x4 equal to x3 minus f of x3 divided by f dash of x3. So it is equal to x3 minus x3 log x3 to the base 10 minus 1.2 divided by 0.43429 plus log x3 to the base 10, and we know that x3 is 2.74065. When you substitute x3 in this equation, we get x4 as 2.74065. So you can observe x value is 2.7406 correct to 65, correct to 4 decimal places. Now, seventh problem. Using Newton-Raphson method, find the real root of the equation log x minus sin x equal to 0, correct to 3 decimal places. Solution. Write the given things. F of x is log x minus sin x. F dash of x, derivative of log x is 1 by x. Derivative of sin x is cos x. Here x naught is not given. This is most important thing. Now we have to find x naught. So to find x naught, first we have to write given equation f of x equal to log x minus sin x. Here f of x contains trigonometric function, that is sin x. So we have to use calculator in radian mode. So we start with a trial and error method. We have to get the condition f of a into f of b is less than 0 first. So we start with f of 0. F of 0 is 0. F of 1, we get it as minus 0.8415, which is less than 0. F of 2, which is minus 0.2162, which is again less than 0. We have to get f of a into f of b less than 0. So f of 3 is 0.9575, which is greater than 0. So one value here less than 0 and another value here is greater than 0. So f of 2 into f of 3 is less than 0, which implies there exists at least one real root in the interval 2, 3. Now the next question is, we have to choose which value as x naught. We already said in the note, we have to choose x naught as whichever value of f of a or f of b tends to 0. Now you can see here f of 2 is minus 0.2162 and f of 3 is 0.9575. So out of these two, which value tends to 0 faster? Definitely it has to be f of 2. which tends to 0 faster than f of 3. So we take x naught as 2. We take x naught as 2. The Newton-Raphson method is given by the formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, etc. Now the first iteration, n equal to 0, the formula becomes x1 equal to x naught minus f of x naught divided by f dash of x naught, that is x naught minus log of x naught minus sin x naught divided by f dash of x naught is 1 by x naught minus cos x naught. Here x naught is 2, so we get x1 as 2.2359. Now the second iteration, the formula is x2 equal to x1 minus f of x1 divided by f dash of x1. So substitute x1 minus f of x1 is log x1 minus sin x1 divided by 1 by x1 minus cos x1, and we know the value of x1 2.2359, so we get x2 as 2.2192. Third iteration, for n equal to 2, x3 is x2 minus f of x2 divided by f dash of x2, that is x2 minus log x2 minus sin x2 divided by 1 by x2 minus cos x2. We know that x2 is 2.2192. When you substitute in this equation, we get x2 as x3 as 2.2191. So therefore required root is x value as 2.219 correct to 3 decimal places. You can observe 2.219 here also. Now eighth problem, find a real root of the equation x cube plus 5x minus 11 equal to 0 by applying Newton-Raphson method. Carry out 3 iterations. Again students, here also you can observe x naught is not given. Solution, first write the given data. F of x is x cube plus 5x minus 11. F dash of x, derivative of x cube is 3x square, derivative of 5x is 5, derivative of 11 is 0, x naught is not given. So first we have to find x naught. To find x naught, the condition is we have to choose a and b such that f of a into f of b less than 0. So we start with f of x equal to x cube plus 5x minus 11. We try trial and error method. So we start with 0. F of 0 is minus 11, which is less than 0. F of 1, we get minus 5, which is again less than 0. F of 2, we get it as 7, which is greater than 0. So our condition f of 1 into f of 2 is less than 0 is satisfied. So there exists at least one real root in the interval 1, 2. Now we have to choose x naught. We have to choose x naught in such a way that whichever value of f of a or f of b tends to 0 faster. So here minus 5 tends to 0 faster than plus 7, right? So we choose x naught as 1. The Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, etc. Now first iteration, for n equal to 0, formula is here. x1 equal to x naught minus f of x naught divided by f dash of x naught. It is equal to x naught minus x naught cube plus 5x naught minus 11 divided by 3x naught square plus 5. So here x naught is 1, so we get x1 as 1.625. Second iteration, for n equal to 1, x2 equal to x1 minus f of x1 divided by f dash of x1. This becomes x1 minus x1 cube minus 5x1 minus 11 divided by 3x1 square plus 5. So x1 is 1.625. So we get x2 as 1.5154. Third iteration, for n equal to 2, we get x3 is equal to x2 minus f of x2 divided by f dash of x2, which is x2 minus x2 cube plus 5x2 minus 11 divided by 3x2 square plus 5. And we know that x2 is 1.5154. So we get x3 as 1.5106. So after 3 approximations, the required root is x equal to 1.5106. Thank you.